Hello, hello dear students. Today we are going to learn about force and pressure. We'll first learn about contact and non-contact forces. If you see this picture, a car moves in forward direction when a man applies force from behind. Then in next picture, a reluctant dog is being pulled by his master. And in third picture, a boy playing football is kicking the ball away. What do you observe from these pictures? We observe a force act on two bodies through an interaction between them. Also, if you observe these pictures, here some events are there. As seen in this picture, iron nail gets attracted to pole of magnet. These iron nails get attracted towards a pole of magnet due to magnetic force. A coconut is falling from the coconut tree here. Objects are attracted to earth due to force of gravity. When a comb gets rubbed against hair, small pieces of paper kept on a table get attracted to the comb. The comb has an electrostatic charge and there is an induced opposite charge on the pieces of paper and the pieces stick to the comb. So all these pictures shows us some attraction. In last diagram, force is been acting through direct contact of the objects or via one more object. Such force is called contact force. What is contact force? Force is seen to act through a direct contact of the objects or via one more object. Such a force is called contact force. So, in first picture here, these are the contact forces. Muscular force is an example of contact force and is applied to the objects with the help of our muscles. It is applied in several cases such as lifting, pushing, pulling, etc. So, these are the contact force. And what is non-contact force? As we seen in this diagram here, a force is applied between two objects even if the two objects are not in contact. Such a force is called a non-contact force. What is non-contact force? Force applied between two objects if the two objects are not in contact, and such a force is called non-contact force. Forces like magnetic force, gravitational force, electrostatic force acts without a contact. Therefore, these are the examples of non-contact forces. Then balance and unbalanced force. Here in this picture, on both sides, if we keep same weight, that is balance force will apply, and if you keep weight more weight on one side and somewhat less weight on another side, there will be unbalanced force. If several forces are applied on an object in the same direction, a force equal to their addition acts on the object. Several forces are applied on an object in the same direction. The force equal to their addition acts on the object. If two forces are applied on one object in direction opposite to each other, a force equal to their difference acts on the object. And third one, a force is expressed in magnitude and direction. A force is a vector quantity. These points you have to consider while study the balance and unbalanced force. Then what is inertia? We have seen that an object changes its state of motion due to force. Object changes its state of motion due to force. In the absence of force, object exhibit a tendency to remain in its existing state of motion. So, what is inertia? The tendency of an object to remain in its existing state is called inertia. Tendency of an object to remain in its existing state is called inertia. This is why an object is stationary state remains in the same, and an object in motion remain in the state of motion in the absence of an external force. Means if you not apply the external force, external unbalanced force, the object, if it is stationary, it will remain as it is in the same state. Or if an object with its motion, it will be in the motion state. Then we'll see about types of inertia. There are three types of inertia. First one is inertia of state of rest. An object in the state of rest cannot change its state of rest due to its inherent property. This property is called the inertia of state of rest. Means if the object in state of rest, it remains as it is in the rest state of rest. This property is known as the inertia of state of rest. And next, inertia of motion. The inherent property of an object due to which its state of motion cannot change is called its inertia of motion. For example, a revolving electric fan continues to revolve even after it is switched off. Passengers sitting in the running bus gets jerked in the forward direction if the bus suddenly stops. Third type of inertia is directional inertia. The inherent property of an object due to which the object cannot change the direction of its motion is called directional inertia. Here, the direction will not be changed because of inherent property of the object. For example, if a vehicle in motion along a straight line suddenly turns, the passengers sitting in it are thrown opposite to the direction of turning. So this is the directional inertia. Then we'll see about pressure. What is pressure? A force exerted perpendicular on a unit area is called pressure. Force exerted perpendicularly on a unit area is called pressure. Pressure equal to force upon area on which the force is applied. What are the units of pressure? The SI unit of force is Newton. And area is measured in meter square here. Therefore, the SI unit of pressure is Newton per meter square. It is also known as Pascal. In atmospheric science, the unit of pressure is bar. 1 bar equal to 10 raised to 5 Pascal. And pressure is a scalar quantity. If area increases, pressure reduces for the same force. And if the area decreases, pressure increases for the same force. For example, due to the natural adaptation of bottom surfaces of camels' feet are broad. Hence, the camel's weight is exerted on a large area and the pressure on the sand is reduced. This is why camels do not penetrate into the sand and it becomes easy to walk. Pressure on the solids. Air pressure is exerted on all the objects kept in air. When a weight is kept on a solid, pressure is exerted. Here in the picture, we kept the books, means weight, on a solid. If we weight keep the weight on a solid, pressure is exerted on it. This pressure depends on the value of weight and the contact area between the two. Then pressure of liquid. If you see these pictures, you will get idea about pressure of water. So see here the level and pressure of the liquid. The jet from the lowest hole falls faster from the bottle. Here jet from the lowest hole falls faster compared to this topper hole. Any one level the liquid pressure is same. Also the pressure increases as the depth of the liquid increases. Here depth of the liquid helps to increase the pressure, and because of that there is a falling of water fastest on bottom area. Then gas pressure. If a balloon is inflated by filling air by mouth, it inflates on all sides. If a balloon is inflated by filling air by mouth, it inflates all sides. All gases and liquids have the common name, that is fluid. A fluid in a container exerts pressure from within on the walls and bottoms of the container. A fluid enclosed in the container exerts its pressure equally in all directions at a point within the fluid. Then we'll see about atmospheric pressure. Air surrounds the earth from all sides. This layer of air is called atmosphere. Atmosphere exists to about 16 km height. It further extends up to about 400 km in a very dilute form. The pressure created due to the air is called atmospheric pressure. What is atmospheric pressure? The pressure created due to air is called atmospheric pressure. Imagine that a very long hollow cylinder of unit cross sectional area is standing on the surface of the earth and it contains air. Weight of this air is the force applied in the direction of the center of the earth. This means that atmospheric pressure is the ratio of this weight divided by the area of the surface. The air pressure at the sea level is called 1 atmospheric pressure. Air pressure decreases as one goes up in height from the sea level. Air pressure decreases as one goes up in height from the sea level. 1 atmosphere equal to 101 into 10 raised to 3 Pascal or 1 bar. That is also 10 raised to 3 m bar. 1 m bar equal to 10 raised to 2 Pascal, hectopascal. We constantly bear the atmospheric pressure on our head. However, the cavities in our body are also filled with air, and arteries and veins are filled with blood. Therefore, we do not get crushed under the water and due to atmospheric pressure. As the pressure is balanced, the Earth's atmospheric pressure decreases with height from the sea level as shown in this figure, goes on decreases if height is increased from the sea level. Then we will say about beyond force. What is beyond force? The upward force acting on the object in water or other fluid or gas is called beyond force. Here on plastic bottle, the force is acting towards upward direction and that force is called as beyond force. An iron nail sinks in water, but if you see the massive steel ship float on the water. Why it is so? When an object is deep in a liquid, a buoyant force acts on it, and hence it appears that the weight of the object is reduced. It becomes easier to swim in seawater than in fresh water. Why it is so? This is because the seawater is higher than the density of fresh water. The density of the seawater is higher than the density of the fresh water due to salt dissolved in sea. Because of this, it becomes easier to swim in water than a seawater than a fresh water. How is it decided that an object left in liquid will get sink in the liquid, will float on the surface, or will float inside the liquid? First, the object floats if the buoyant force is larger than its weight. Number two, the object sinks if the buoyant force is smaller than its weight. And number three, the object floats inside the liquid if the buoyant force is equal to its weight. Then we'll see about buoyant force and Archimedes principle. When the stone is sunk in water, the buoyant force acts on it in the upward direction. The weight of the stone acts downward. Therefore, the force which acts on it in the downward direction is effectively reduced. Then we'll see about Archimedes principle. This principle states that when an object is partially or fully immersed in a fluid, a force of buoyancy acts on it in the upward direction. This force is equal to the weight of the liquid displaced by the object. So, what is Archimedes principle? Archimedes principle says us when an object is partially or fully immersed in a fluid, a force of buoyancy acts on it in the upward direction. This force is equal to the weight of the fluid displaced by the object. The use of Archimedes principle is very wide. This principle has been used in the construction of ships and submarines. The instruments such as lactometer, hydrometer are based on this principle. Now we'll see density of a subject or relative density. What is density? Density is the ratio of mass and volume of the object. The SI unit of density is kilogram meter cube. The property density is very useful in deciding the purity of the substance. The relative density of a substance is expressed, that is relative density equal to density of substance and divided by density of water. So, this is a ratio of two equal physical quantities. It has no unit. Relative density of substance is called its specific gravity. So, dear students, We already learn about different concepts related to force and pressure in this chapter. Now we have to read the lesson which is in textbooks and solve the exercise. If you have any doubts about this lesson, you have to call me on this number which is on screen, or you can write your questions in WhatsApp. Thank you.